Okay, today's lesson we're going to look at circular motion. So all the motion we've dealt with so far has been in a straight line, so now we're going to start looking at things that go around and around in a circle. So for example, let's suppose we have some sort of object on a string and we're going to spin that thing around in a circle, and let's suppose we spin it around clockwise, so this thing's going to go around and around and around. So let's look at how the directions are going to work. So because it's going around in a circle, its velocity is always going to be pointing outwards. So if that string broke, that thing would just launch in a straight line because we've got nothing holding it to be in a circle anymore. So then it'll just go, once the string breaks, it'll just get released and then it'll travel in a straight line. So if at that location our velocity would be over there, but if our new location's down here, it would have a velocity like that, and so on. So as this thing travels around and around, the velocity is constantly changing. So even though it has the same speed, right, if we're spinning this thing around and around at the same speed, we do have changing direction. And remember, velocity is a vector, so therefore either the speed or direction changes, that's going to mean that the velocity is changing. So therefore, velocity is constantly changing. And if we have changing velocity, that'll mean it is constantly accelerating. Actually, I don't need to use the word constantly. So that's the key idea. So if we have our velocity that's changing as it's going around and around because our direction's changing, that means then we have acceleration. Okay, so the key thing to understand with circular motion is even though the speed itself doesn't change, right, it can be moving at a constant 2 meters per second or whatever, but because our direction's changing, that means then our object has to be accelerating. If our velocity is changing, that means we have acceleration. So the question is, what direction is our acceleration? And what are we going to call it? So in this case, our acceleration will always be going inwards because that's the way we're pulling it, right? So if you're spinning something around and around, you're pulling this towards the center. So that means our acceleration will be inwards towards the center. So no matter what location, our acceleration is inwards. So, and we call that centripetal acceleration. So centripetal acceleration going towards the center of the circle, and then because our acceleration is towards the center, that means our force is also towards the center because our force and acceleration have to match in the same direction. So then we call it our centripetal force. So centripetal comes from an old Latin word basically meaning towards the center or center seeking. So centripetal acceleration, centripetal force is always going to be inwards. Okay, so that's sort of what takes care of it in terms of directions and which way things are going to go. So our next step then is we actually got to do some calculations with this stuff. So if we have something traveling in a circular pattern, let's start with, first of all, its velocity. So we know its velocity is going to be pointing outwards, but how would we calculate it? So velocity, and we're going to deal with this as being relating to what we already know. We know our velocity equals distance over time. So that means our circular or centripetal velocity then will be the distance that it makes in one rotation. We don't want to go around and around and around 10 times. Let's just do one rotation to keep it simple. So that means our distance then around one path of the circle is its circumference. And the formula for circumference is 2 pi r. And because we're dealing with just one rotation, we're going to actually deal with just the time for one rotation. So we use a capital T, which basically stands for period. So T is period, which means time of one revolution. Okay, so if we go around the circle once, the time it takes to go around once is our period. So that's the number we're going to use. We're going to use the distance for one circle, one cycle, and the time it takes to go around that circle once. Okay, so now next is how would we calculate acceleration. So our acceleration can't be figured out so easily. So this one you just got to get the formula. Acceleration ends up being v squared over r. And then our force, we're going to use mass times acceleration from before. So now when we're dealing with centripetal, it'll be mass times centripetal acceleration, which means then we have mv squared over r. So those are three key formulas that we're going to use for circular motion. The only other thing we got to be careful with is sometimes they'll give you the time. Instead of being a time, they're actually going to give you the frequency. So let's start a new page here. So let's suppose I say an object revolves at 20 RPMs. So RPMs means 20 revolutions per minute. So how do we find the t? So if we have 20 revolutions in 1 minute, we would convert that to seconds. So 20 revolutions in 60 seconds, which would mean then we get 1/3. So we have 1 revolution in 3 seconds. So the formula that we use for period, if you get a frequency, because that's what this is, revolutions per second, revolutions per minute is a frequency. So the formula that we use, it's pretty simple. You just do the reciprocal. So in this case, if our frequency is 1 revolution in 3 seconds, our period then would be 1 divided by that, or just flip the fraction. So you'd have 3 seconds in 1 revolution. So that means our period would be 3. Okay, so 20 revolutions per minute means takes 3 seconds to do 1 revolution. So anytime you get that, just make sure you do the reciprocal, change it to revolutions per second, and then you just have to flip your fraction to get the correct answer. Okay, so basically that's it for circular motion. So we have our 3 formulas. Sometimes you'll get a question where you might have to do them in order, so you might have to figure out the velocity first, and then from velocity you can figure out acceleration or force, or you might have to get your period first, something like that. Okay, so let's look at an example. So we have a horse running around a circular track. The question is asking what's its centripetal acceleration if the track has a radius 10 and it takes the horse 14 seconds to go around the track. So use our formula for acceleration, so v squared over r. But you can see in this case we don't know the velocity, so we have to find the velocity first. So that'll be 2 pi r over t. So on your calculator, figure that out. So 2 times pi times 10 divided by 14. So when we do that, we get an answer of 4.5 roughly. So that's our velocity. So now we can actually calculate the acceleration. So we'd have 4.5 squared divided by the radius of 10, and we're done. So when we square that answer, divide by 10, we get an answer of 2.01, and we'll just round it off to 2 digits, so 2.0 meters per second squared. So they're pretty easy formulas. Like I said, the only thing sometimes you have to do is do one of the calculations first and then use that answer to plug it in. One other option you could do for this kind of question is you could substitute the equation in. So you could use a equals v squared over r, and then we can just substitute the 2 pi r over t in for v. So we'd get that, and then you actually multiply it out, we'd get 4 pi squared r squared over t squared, and that's also going to be divided by r, and we can see one of the r's cancel, so you'd have 4 pi squared r over t squared. So that's another formula for acceleration, but it just combines the other two. And this formula is on your sheet. You can use it if you want. You'll get the exact same answer that we just got, the 2.0 meters per second squared. So if you want to do that, you can. Otherwise, I would just recommend find the velocity first, get that answer, and then plug it into the acceleration formula afterwards. Okay, so let's do one more example. So in this case, we have a man spinning on a centrifuge. So that's just a big merry-go-round that's going to spin him around and around. The question's asking what's the force acting on him. So we'll use our centripetal force formula, so mv squared over r. We know his mass. We don't know the velocity, but we do know the radius. So 8.8, so the only trick is we need to figure out what the velocity is. So our velocity will be 2 pi r over t. So our centripetal will go 2 times pi times 8.8 divided by t, but we don't know the t because this is in revolutions per minute. So we have to do that conversion too. So 15 revolutions in 1 minute will equal 15 revolutions for 60 seconds. So that would equal 1 revolution in 4 seconds. So our period then will be the flip of that. It'll be 4 seconds for 1 revolution. So that's the answer we're going to use. Period will equal 4. So we'll plug that in our velocity formula. So 2 pi times 8.8 divided by 4. We get an answer of 13.8 meters per second. So that'll be what we'll put in over here. So 13.8 squared times 100 divided by 8.8. We get an answer of 2169 newtons. And we can round this off. Everything was 3 digits or 2 digits or whatever. So you can leave it at that, or if we put it in scientific notation, 2.2 times 10 to the 3 newtons. And we're done. So you can see the basic formulas. Like I said, sometimes the hardest part is you just have to do a couple steps in order to get the numbers or the variables that you need to solve the question. And that's all.